Sebab ada setengah dia terus dapat block diagram sini, dia tak tunjuk macam mana mathematical equation tu. Okay, dikeluarkan. Kemudian kita ada output dan juga input. So selepas tu bolehlah dapatkan dia punya overall transfer function. Yang ni pun dia tak selesaikan lah, tapi kena selesaikan, nampaklah apa dia punya term, certain term yang ada dalam tu. Okay, so itu dari segi projek lah. Sebab ramai yang hantar balik salah lagi kan. So saya minta maaf lah, bukannya ni saya ikut seperti mana dalam proposal. Kalau proposal, dalam instruction. Kalau instruction tu kata nak dalam industri, benda tu ada dalam industri lah. Industri pembuatan ke ataupun industri pemprosesan ke. Tapi kalau di luar macam dia adalah satu fasiliti, kena tunjukkanlah fasiliti tu adalah alat dalam satu industri tu. Contoh macam tu. Okay. So sebab tu saya banyak reject yang itu. Satu lagi dia tak ada derivation. Dia pakai yang jenis eksperimen, input output, terbinalah model kan. Daripada input output dia dapatkan model terus, tak ada mathematical equation. So yang tu saya memang reject je. Ataupun saya suruh cari, kalau tak ada kena tukarlah tajuk lain. Okay, saya ingat yang tu semua orang faham Alright. So kita dah habis dah sikit projek. Sepatutnya proposal semua dah okey. Jadi untuk kehadiran hari ini sila isi siapa yang ada masalah banjir ke apa, kawan banjir ke bagi tahu. Ataupun nanti lepas cuti. Bukan saya nak terlalu strict sangat pasal kedatangan, tapi sebab saya nak pantau lah sama ada wujud tak student. Jangan kata saya tak consider sebab banjir ke apa, tapi disebabkan saya tak nak ada student yang terceceh disebabkan bukan perkara-perkara yang sepatutnya lah. So yang tu semua orang kena ambil berat lah kan. So tanggungjawab kita sebagai seorang pelajar kan, belajar, bukan pergi ke mana-mana atau buat selain daripada tu, kecuali yang terkesan banjir lah. Okay. Yang tu tak apa, boleh tengok video kalau saya terangkan. So dan GC tadi tu kita tengok section 9, sebab 9 dengan 11, 10 dengan 12 kan. Okay. So dekat situ kamu boleh tengok yang kita ada week sampai 14 je. Sekarang ni adalah minggu ke-12 So lagi 3 minggu je lagi ni. So kita ada dua-dua lah ni. Root locus 1 dengan root locus 2. Ni 1, ni 2. Ni second Okay, ni lah root locus 1, root locus 2. Okay.
Doktor.
Ya.
Boleh tandakan untuk saya ke?
Nama apa?
Haikal Aziz.
Haikal.
Sebab saya tak ada, dia kata not register.
Muhammad ke apa?
Tak ada Muhammad.
Tak ada nama awak Haikal. Haziq Haris. Haris Irfan, Haris Zafran, Haziq Fahmi. H kan nama awak kan?
Saya scan pun tak lepas tadi.
Sebab nama awak tak ada lah dalam list. Dulu sebelum ni ada tak?
Sebelum ni semua pakai Google ni je. Pakai Google Form je.
Saya dah lama dah. Dua kelas saya pakai ni. Yang mana GF tu saya pakai untuk section yang saya tak ada list je.
Tak ada list.
Sebelum ni dah 2 kali saya pakai yang section berapa kan?
Saya section sebelah 12 kan?
Oh, patutlah. Sebelah 12 guna GF. Sekejap, saya dah bagi link kan dekat situ?
Link. Saya salah masuk grup pun ni.
Link doktor bagi tu untuk 19 bulan 12 kan?
19 bulan 12?
Saya buka je di 19 bulan 12.
Oh, okey. Nanti saya ubah. Sebenarnya saya ni 26 saya dah letak kat situ. Tapi saya dekat sini nanti saya kena ubah Sekejap.
Okey.
26 12. Okey, terima kasih Muhammad.
Okey, terima kasih.
Dah betul kan? Cuba
Betul
check.
betul.
Betul
Saya pakai Google Form kan.
11-12 pakai Google Form.
Okey doktor.
Okey, saya pergi laju je untuk root locus ni. Apa yang kita kena tahu je dalam root locus?
Doktor, saya tak sempat nak scan. Saya baru join.
Section berapa Irfan?
Sekejap. Saya
Sekejap saya letak je lah sini, tak apa. Ni section 11-12 kan, okey. So kita boleh tengok sekecil je nota kita kat sini. Nampak tak Irfan?
nampak. Doktor, tak nampak QR.
Okey, nampak sekarang? Okey
Dah, doktor. Jap.
Alright. So untuk root locus, perkara yang kita kena tahu adalah kenapa kita nak lukis root locus? Dan apa dia root locus? Root locus is a plot of closed loop pole location as a function of parameter value. Root locus is a plot of closed loop poles. Walaupun kita guna closed loop pole, tapi kita akan dapatkan dia punya roots using open loop. Once we have the plot of how the poles move, it is simple to select a parameter value that yields desirable pole location. This is the idea behind root locus design. So kita boleh tengok by moving the poles, we can see the response, the response of the system in the time domain. Why do we need to know about root locus? To control a system with complex dynamic when we design the controllers. Goal for the root locus. What is the root locus? Actually, is a graphical information about the system behavior when the controller is working. Alright, I think finish for attendance. For example, we have this block which is K, G and H. So G will denote either first order or second order. First order or second order. So we have K, we call it proportional gain, and a single pole at S equals to minus A. So what is closed loop transfer function? Closed loop transfer function is Kg divided by Kg divided by 1 plus Kgh. So this is the closed loop transfer function. What is the characteristic equation? The denominator will be our characteristic equation. What happens if A equals to 1? A equals to 1. So we plot the poles, and then the pole will move, the locus will move to the infinity. So what happens if we have two real poles? We have we need to solve again for closed loop and determine the characteristic equation to get the breakaway point. Breakaway point. Now what happens if we have two poles? What is the locus looks like? So the locus will plot as what is the roots location. Di mana locus akan terbentuk bergantung kepada kedudukan poles. Okay, kedudukan poles. Okay, for this example, we have two poles, negative A, negative B. So we have the response of zeta. Okay, this one will locate also the zeta. Okay, maybe we can see the summary here. Okay, let's say we have two poles. Okay, so this is the transient and also the steady state. Okay, we have two type, which is overdamped and critically damped. Okay, overdamped and critically damped. Okay, this is a kind of overdamped. Okay, overdamped we have two different pole. This one critically damped, similar pole location. Okay, critically damped di atas sikit daripada overdamped. Overdamped tu dia graf dia kat bawah. Okay, so for underdamped we have overshoot. Okay, remember if it's zeta between 0 and 1, we have overshoot. Okay, what happen if we have the imaginary value of J, let's say J3, J minus J3. So we have oscillate. So this kind of pole location will determine the time response. Okay, so for example, this is unstable because of the right half plane location of poles. So we have amplifications of the signal. Okay, similar to this one. Okay, we have if it's similar A, then it's critically damped, but it's unstable, so it's going nowhere, or it's amplified. Okay, we have this one, two at same location. We call it as what? Two same poles. We call it as critically damped. Okay, so we have a lot of different locus. Okay, different root locus. So graphically, if we have one pose, okay, we will plot it from the, okay, all the locus will start at pose and at 0 or infinity. 0 or infinity. Dia akan berakhir di kosong atau infinity. Bermula daripada pose. Bermula daripada kutub, berakhir di 0, atau bermula daripada kutub dan berakhir ke infinity sekiranya tak ada 0. Okay, so kita ada, if we have two poles, then it will end at 2 infinity. So the number of poles minus number of 0 equal to the number of branch that will ends at infinity. That branch ends at infinity. Okay, so like this one, we have two poles, minus 1, 0, so equal to one branch and at infinity. Okay, this is for the example how we know that the locus end at 0 or at infinity. Okay, so this one is similar from number 5. Okay, number 6 is similar to number 5 but different pattern, because start from the poles and at 0, start at the poles and at infinity. Okay, so here we have two poles and 1 0 as well, but different location. So different location will determine different patterns of the root locus. Okay, so we need to do the sketching or graphical representation using the open loop transfer function, so that we know different pattern from different location. Okay, so this is the rules to generate the root locus. Okay, we will use this rule using 1 to 4 example, and then we will familiar with the step. Okay, so this is just a step how to draw the root locus. Okay, later we will see using the example. Alright, so here we have the term. What is the characteristic? What is the so-called overall transfer function or closed loop transfer function? Alright, so what else we need to know? Okay, this is start the rules. Okay, rule again. Rule 4, rule 5, rule 6, rule 7, rule 3. Okay, if you have notes from I mean the summary of the rules. If you have the summary of the rules, then you can read from there. Okay. So we have a basic rule for sketching the root locus. 1, 2, 10, 6, 7, 8, 9. Okay, to 9. We have until calibrate the root locus. Okay, or it depends on the case. If there is a pose, okay, in the complex area, then we need to calculate the angles of departure. Okay, so this is the example. Alright, finish. So we have summary. We need to know the root locus because we want to design a controller for the system. So that is the note number 1. Okay, for note number 2, we will see the application of MATLAB. Okay, we will apply MATLAB software to draw the root locus. Okay, when we learn how to draw it or sketch it manually, then we will appreciate very well that the root locus sketching is not as easy as to draw it. Okay, but using software, we can just use the denominator and numerator and then use one line of coding to plot the root locus, and we know the characteristic of zeta and so on inside the root locus that we draw. Okay, so I think we will use the whiteboard. Okay, so the first example is quite simple. It's quite simple. We will have one proportional and one A value. Okay. Please let me know if you cannot see. Yeah.
Ada student belum dapat masuk lagi.
Okay, dah. So we have this kind of open loop transfer function, which is GH. Alright. So what is the poles? What is the zero? The Kp is our proportional gain. The Kp is our proportional gain. So this is our GH. Okay, this is our GH. Okay, first step, we need to know what is the zero open loop. Okay, what is our zero? Nil. Okay. What is our poles? Okay, our poles is at 0. Okay, S equals to 0. 0.1S plus 1 equals to 0. So S equals to 10. Minus 10. So our poles is 0 and minus 10. Okay, next step, we need to find the asymptote. Okay, we have two kind of asymptote. One is the value and the other one is the asymptote angle. Okay, we have first we have the value. Okay, asymptote value. Let's say asymptote value, we call it as x. Okay, meaning the asymptote cut the real axis at x equals to, okay, the summation of poles minus summation of 0 divided by the number of pole minus the number of 0. Okay, number of poles m minus number of 0. M for the denominator and for number of numerator. Okay, number of roots at numerator. Okay, so number of poles equals to minus 10 divided by m minus n, 2 minus 0. 2 minus 0. 2 minus 0. So equals to minus 5. Okay, and then we have, this is asymptote that cut the real axis. Cut at real axis. So we have angle. Okay, let's say we make it short. Angle of asymptote. Okay, angle of asymptote we calculate using the formula of 1 plus 2k times 180 degrees okay, sorry, n minus m, and okay, number of poles minus number of, okay, actually it's number of poles minus number of 0, but let me see the what we call it, okay, the symbol okay, the symbol n minus m or m minus n, n minus m, okay, n minus m. Okay, so this is 1 plus 2k. Okay, what is the k? K is actually equals to, what is the value until n minus m minus 1. So if we have 2 here, 2 minus 0 minus 1. So we will have k equals to, okay, let's say we have n equals to 2 minus 0 minus 1. So until 1. K is until 1. So k equals to 0, 1. Okay, 0 to 1. 0, 1. Alright, so if all this term equals to 2, then k equals to 0, 1, 2. Okay, but here it's up to 1. Okay, so we have 1 plus 2k, 180 divided by n minus m. N minus m equals to 2, right? So 2. 1 plus 0, so 180 degrees. And the other asymptote, Okay, let's say this is asymptote 2. Okay, we have 1 inside here. So we have 2 times 1, 2 plus 1 equals to 3. 3 times 180 degrees divided by 2. So we have 90 degrees here. And then 90, 270. Okay, 270. 90 times 3. This is 180 divided by 2, 90. Okay, 90 times 3 is 270 degrees. Alright. So what is the K? K is here. Now we have asymptote x minus 5 and the angle of the asymptote equals to 217. Okay, next step is we need to find the breakpoint.
Doktor, lupa tanya.
Ya.
Kalau logik ke kalau kita punya
Apa dia?
Sekejap nak tengok whiteboard boleh ke doktor?
Whiteboard. Okay, whiteboard.
Logik ke kalau nilai K kita tu kosong?
K kita tu kosong.
Kosong saja. Maksud K kita tu ada 1 je dan nilai dia kosong.
So 1 je lah. 1 tolak kosong, tolak 1 kosong. Boleh? Dia ikut yang ni. Kita ikut yang ni, yang saya garis ni. Logik lah. Kalau awak kata tu ni sebabnya dia boleh jadi 1 for kutub kan.
Okay. Okay, doktor.
Jadi 1 tolak 1 dia jadi kosong lah.
So kita punya angle pun ada 1 je lah.
Ya.
Okay.
Jadi mungkin angle kita kat sini je.
Alright. Thank you, doktor.
Alright.
Doktor,
Ya.
macam mana S bila dapat negatif 10 ni?
S sama dapat
Saya tak berapa nampak.
Oh yang ni
Ya.
0.1 S sama dengan tolak 1. Dapat? Dapat?
Okay, dah nampak.
Nampak Nampak? Okay, terima kasih. So nombor 3. Nombor 3 kita nak pilih, nak cari breakpoint. Okay, breakpoint we use the characteristic equation. Okay, whereby we use 1 plus kgh. Kgh equals to 0. Okay, what is our kgh? What is our kgh? 1 plus gh. 1 plus kgh. H equals to 1. Okay, we have 1 plus kp s 0.1 s plus 1. H equals to 1. Okay, h equals to 1 equals to 0. So we have here s 0.1 s plus 1 plus kp equals to 0. Okay, we have kp equals to minus s 0.1 s plus 1. Okay, kita bezakan kita bezakan kp di kp over ds. So we get s equals to minus, okay ni dah tak ada minus 1 tu we not consider anymore, minus 2. So ni minus ni daripada sini 0.2s equal to minus 1. Okay, divide by 0.2. So it's minus 5. Okay, we have minus 5 for breakpoint. And then we can calculate for KP at breakpoint. Okay, what is our value? KP at S equals to minus 5. So what is our KP at breakpoint? KP at breakpoint. Okay, 0.5 plus 1. This is minus. Okay. So 5 times 0.5. Okay. 2.5 2.5. Okay, now we try to sketch the root locus. Okay. Okay, refer to the poles. 0, 0. Okay, when we sketch, you can use the ruler sometimes for the axis, for the axis. Tapi lambat lah kan. So awak draw tu pakai tangan je. Tapi we need to draw using graph paper sebenarnya. Kena pakai graph paper. Sebabnya kita nak apa? Nak cari coordinate S operation tu nanti. Okay, tapi for all this kind of example tak payah. Tak payah. Jadi kita draw dia punya poles dulu, kosong. Okay, betul-betul lah dekat kosong ni. Dah terpadam pula kan. Okay, so kita ada J omega dengan sigma. Okay, dekat kosong dengan dekat tolak 10. So kalau kita buat poles, okay, we use the cross symbol ni, cross symbol. Okay, so we draw the asymptote. Okay, asymptote we use minus 5. Okay, minus 5. Okay, mungkin kita boleh pakai color lain lah untuk asymptote kan. Lambat ni, lambat. Okay. What else? Kita ada sudut 90 degrees. Tu saya dah buat lah 90 degrees. So dia kira 90 degrees from here. Macam tu. 90 dengan 270 dia kata. 270 macam ni. Okay, 270. So we have 90 degrees and dia ada 270 degrees. Okay. Now start from the poles. Okay. Remember the root locus start from the poles and then it will end at infinity or 0. If there is no 0, then both branch will end at infinity. So dia akan follow, dia akan pergi ke titik pecah, breakpoint. Dia akan pergi ke breakpoint. Okay. Kalau dalam physical class kita guna color lah. Baru nampak sikit kan the difference between axis dengan locus lah, dengan root locus. Okay, so kita pergi ke sini dan sini. Okay, kita kena pakai color. Okay, so that we will see the difference between axis line dengan locus line. Okay, macam tu. So sekarang kita buat anak panah dia, meaning that dia akan pergi ke infinity. Okay. So what is the value here is -5 pada titik pecah. Kebetulan titik pecah is coincide with the asymptote. And then we have the KP. So the KP value at titik pecah ni, breakpoint ni adalah 2.5. Okay, so kita nak sketch what we call it, root locus saja kan. Okay, so itu adalah A. Kita try to draw different open loop transfer function. We have B. Okay, we have B, K per S plus 1 squared. This is KG. This is GH. Sebenarnya ini adalah KGH because of the apa ni kita panggil? Gain, proportional gain. Okay, so we have GH. Okay, yang ni saya tulis GH je kan. Then we can find for KP. Okay, actually KP ni adalah pada what we call it, breakpoint. KP at breakpoint. But for KP dekat sini will be different. So once kita gerak ni, KP dia akan bertambah. KP tu akan daripada kosong, gain dia kosong sampai dekat sini dia akan berubah. Okay, so ini K. So tentukan K pada titik pecah je untuk case B. Okay, so first step is our poles and 0. Okay, 0 is the numerator. Okay, roots of numerator. So nil. So poles S equal to 0, S equal to -1. Okay, remember when we have two poles at similar location, then we call it the critically damped. Okay, critically damped. Okay, this is the first step. So from this one, we know that 3 branches and berakhir at infinity. Okay, step number 2, find the asymptote. Okay, we have value, asymptote value and the angle, asymptote angle. Alright, so for asymptote value, we have the summation of poles minus summation of 0 divided by number of pole minus number of 0. Okay, we have -1, -1, 0. Okay, 0 tak adalah apa-apa kan. Then divide by 3 minus 0. Okay, we have -2 over 3. Okay, berapa dalam perpuluhan ni? Minus 0.67. Okay, untuk sudut asymptote, kita ada the first ataupun kita buat dia punya general formula lah. General formula 1 plus 2k 180 degrees divided by n minus m. So what is the k? K is 0 until n minus m minus 1. So we have 3 kan, we have 3 kat sini. 3 minus 0 minus 1. So kita ada k sampai 2. 0, 1, 2, 1, 2. 3 tak ada lah. Dia sampai 2 je. Kan? K, 0, 1, 2. So kita ada alpha, sometimes using alpha, sometimes using ni kan. 1, 2, 3. Okay. 1 plus 0, 180 divided by 3. This one, 1. Okay, we have 3 times 180 divided by 3. Okay, the other one, 5 4 plus 1, 5 times 180 divided by 3. So we have 60 degrees. This one, 180 degrees. This one we have 60 3 kali 6 kan, 60 times 500, 300 degrees. 300 degrees. Okay, that is the second step. So our third step is breakpoint. Okay, make sure that we sketch initially for what is pose 0, minus 1, minus 1. Okay, let's say this one. And then we have 60 degrees at what is the asymptote? Minus 0.67. So this is one right here. So it's 60 degrees, like we use this one. And the other 300 degrees, 300 degrees macam mana? 180, 180, 180 times 180 times. Okay. Ni boleh sampai 180 je kan? 0, 90. Dia sampai macam tu je lah. Okay. So 300 actually yang inilah, yang dekat 90 ni kan. Okay, ni 180. Kita ada macam ni. 300 sebab dia simetri. Dia simetri. Dia simetri ya. So ni adalah 60. Ni adalah 300. And then kita ada 180. Sampai sini lah. Kan? Okay, ni kita sketch dulu. Kita sketch dulu. So dia akan macam ni. Dia macam ni. So dia akan pergi ke satu titik pecah 0.67. 0.67. Dan dia akan ikut asymptote yang ini dua. Dia akan macam ni. Dan satu macam ni. Dan kita ada dua kat situ. So satu start masuk ke titik pecah. And then we have one left here. Go to infinity. Okay. Alright. So kita akan ada macam tu lah.
Doktor.
Ya?
Kiranya untuk yang soalan 2 ni memang kita tak kira breakpoint dia
Ada. Ni next ni nak kira breakpoint. Okay, so the breakpoint. One plus kgh. Kalau kita tak kira breakpoint, kita tak tahu dia akan keluar ikut mana. Takkan kita nak ikut asymptote kan? Not necessary at asymptote. So kita kena kira juga breakpoint tu. So kita ada 1 plus the original equation daripada yang atas ni lah. 1 plus k s plus 1 equal to 0. Okay, lepas tu kita ada k adalah minus s squared plus 2s plus 1. Okay. And then kita kena bezakan terhadap S. Okay. So bila kita bezakan terhadap S, kita akan dapat 3S squared plus 4S plus 1. Okay, kalau kita tengok yang ni equals to 0, kita boleh faktorkan dia 3s plus 1 with s plus 1. So s we know minus 1/3 and then s minus 1. So kalau kat minus 1 tu is not possible lah. Kan yang ni not possible. So jawapan dia s equals to minus 1.3 which is minus 0.333 kan. Betul tak? Okay, so kita akan lukis dia. Kita akan lukis dia seperti yang kita dah gambarkan kat atas tu. So kita ada apa? Okay, then the axis ni lah sigma nj omega. Nj omega. Okay, then kita ada zero, poles at 0 and then poles at minus 1, minus 1. Okay, 0, kita tanda 0. Okay, let's say just sebenarnya saya ada apa background skill kat bawah ni tapi tak tahu macam mana. Okay, dan kita ada minus 1, ada 2 minus 1 kat situ. And then kita ada asymptote. Asymptote pada 0.67 tu adalah titik asymptote. Okay, minus 0.67. Okay, let's say minus 0.67 tu more than 0.5. So around here lah. Okay, then kita buat 60 degrees. 60 degrees lebih kurang. Okay, kita boleh pakai straight line je, tak apa. Kalau nak pakai dotted pun boleh. Sebab tak ada proper kertas graf kan. So saya pakai straight line je lah. Okay, dia sebenarnya sampai sini je. Sampai situ je. Okay, dan dia ada 300 ya. Yang ni sebenarnya 80 degree je. 180. Okay, yang ni 180. Dan dia ada 360 daripada sana lah. Okay, nak tunjuk betul-betul ni sebabnya dia adalah symmetry. So you can see the symmetrical of the what we call it asymptote angle ni. So kita ada satu lagi breakpoint. Mana 0.33, maksudnya dia breakpoint dia ni dekat less than 0.5. Okay, let's say kat sini lah. Kan? Okay, dia akan pergi ke sini daripada poles. Okay, menuju ke titik pecah. From the breakpoint, dia akan keluar daripada titik pecah. Okay, dia akan kena pada K kat sini. Okay, sekarang ni kita nak kira berapa dia kena kat K sini. Okay, yang tu kita kena buat. We use the characteristic equation. Okay, substitute dia J omega inside S, and then we can find for the K value for the real part and also for the imaginary part. Okay, so kita ada dua cara. Untuk sebenarnya cara ni adalah cara yang sama. We will get the similar answer. Okay, first part ni saya tak habiskan lagi lukis tak habiskan lukis lagi. So first part we use the 1 plus kgh equals to 0, which is characteristic equation. Okay, yang ni kita bawa ke sebelah sini, expand it. Plus K. Okay, then kita buat replacement. S equals to J omega. Inside here. So kalau kita buat J omega kuasa 3, dia akan jadi J kuasa 2 akan jadi negatif 1. J kuasa 2 akan jadi negatif 1. So yang ini jadi negatif J omega kuasa 3. Okay. S kalau kita ada J omega kuasa 2, dia akan jadi negatif omega kuasa 2. So S kuasa 2 tu dia akan tukar omega kuasa 2 plus J omega plus K. Okay, now we factorize the J. Okay, sekarang kita ada real part dengan imaginary part. Okay, real part yang ini. Okay, kita kena gunakan omega dulu kan. So imaginary part Okay, our imaginary part is omega factorize di omega ni. So kita dapat omega is plus minus 1. So sekarang ni replace di omega ni kat dalam ni. Ataupun replace omega kuasa 2. So kalau omega kuasa 2 equal to 1 lah kan. So minus 2 times 1 plus k equals to 0. K equals to 2. Okay. What we know from here is kita ada pintasan pada omega equals to 1. Minus 1 and 1. So if we have this distance as 1, this one is minus 1. Okay, this one plus 1, this is 1 minus 1. Okay, so it's there from the omega. So what is the value k at point 1? So k at imaginary 1 and minus 1 actually is equal to 2. That is the value k at that point. Okay, ini adalah satu cara di mana we use the substitution of j equals s equals to j omega. Okay, the other method is we use the rows. We use the rows because we see that if poles located at imaginary means it's marginally stable. Marginally stable. So kita susun lah ikut rows . Okay, kita gunakan yang ini S kuasa 3 ni. 1 alternately 1 with 1 1 and then 2 with the k. 2 with the k. Okay, or we can write down the equation here lah, baru nampak kan. So from this equation kita susun dekat dalam sini table ni. So we'll see our C, let's say this value 2 kali 1 2 minus k divided by 2 kan. Okay, equals to should be more than 0 lah kan, should be more than 0. This one okay, let's say this one C . Okay, this is k. Okay, kita turunkan k sahaja. So at the limit of stability we have C equals to 2 minus k. So k equals to 2. So we know that k is between 0 and 2. Okay, for a stable system so we'll get the second row which is at k equals to 2. Okay, use second row. 2s squared plus 2 equals to 0. So we factorize the 2 as s squared plus 1 equals to 0. Then we get s equals to plus minus j. Okay, s squared equals to minus 1. So we have j for minus 1, square root of minus 1. Alright. So this is the similar answer with this one. We see omega and we see for k value for stable system. For stable system k equals to 2 and this one k equals to 2. Okay, we can use either one. There is two different methods. Okay, we complete the root locus. Okay, start from the poles. Start from the poles and follow the or come to the breakpoint. Okay, get to the breakpoint and then from that breakpoint it goes to the asymptote and then intersect with the 1 and minus 1. Okay, sebenarnya tak tahu kenapa dia macam tak. Okay, dia sepatutnya very smooth line. Lepas tu dia akan macam sengit sikit kan. Okay, dia sebenarnya curve dia tu cantik dan memotong pada 1 and minus 1 dan follow the asymptote ni. Asymptote, dia takkan kena pada asymptote, dia akan follow bentuk asymptote tu. Okay, so this is from the two poles. So the other one pulse akan pergi ke infinity. Okay, jadi kita akan nampak sebenarnya line yang macam ni. Okay. Alright. So I think that's all for this graph. For this root locus number B. Okay, number C. So saya ada sampai C, D, E sebenarnya. I have another 3. Okay, different pole location and you will know different step. I mean the rest step. Okay, now we know the first step is pole and 0. And then determine the branch and infinity. Okay, and then calculate for asymptote. So we know how it starts and where it's going. And then number 3 is breakpoint. Okay, we know that the locus start from the poles and going into the breakpoint and going up. So from that breakpoint to the asymptote guideline. Okay, so next, what happens if the poles located at complex value? Okay, so you see for C, number C, 1C. Okay, for 1C, I will write it here, C. So we have GH equal to K over S squared plus 4S plus 8. And then we have S minus 4, 16. Okay, we need to find what is the S here. Okay, we use negative B, or you can use your calculator to get the quadratic solution for S. So we have 16 minus 4 negative B plus minus B squared minus 4 AC. So A is 1, C is 8. Okay, all 2 A equals to 1. So you have minus 4 plus minus 16. Okay, 16 minus 32. So it's minus 16. Divided by 2. So you have 2 minus 2 plus minus 2J divided by 2 for the poles inside quadratic. Yeah. So the first step is find for 0. There is no 0. So it's nil. For poles, for poles we have S equals to 0. And then what else? Minus 2 plus 2J is actually minus 1, right? Okay, sorry, this is 2. This is minus 2 plus. So minus 2 plus 2J and then minus 2 minus 2J. Okay, so how many branch? And at infinity, we have 3 branch and at infinity. Okay, so number 2, calculate for asymptote. So asymptote cut at real axis. Okay, we have X asymptote value. Okay, 0 minus 2 plus 2J minus 2 minus 2J divide by 2, 3. 3, right? 3 minus 0, so it's 3. Okay, cancel this one. And we have minus 4. Minus 4 over 3 equals to minus 1.33. Okay, the breakpoint. Okay, not yet. We have angle of asymptote. This one angle of asymptote. Okay, we have angle K, 1 plus 2K, 180 degrees divided by N minus M. Okay, K will be until N minus M minus 1. So 3 minus 0 minus 1 equals to 2. So we have K equals to 0, 1, 2. We have 3K. 3K. Okay, so we have angle 1, angle 2, angle 3. Okay. Okay, let's say this one is K. We have angle 0, K equals to 0, and then angle 2. Alright. So it's 180, 0. Similar to B, right? 3. So it's 60 degree. So this one, 3 times 180 divided by 3. So 180 degrees. Okay, the other one we have 5 times 180 divided by 3. So we have 300 lah. 300. Okay, so that one is asymptote. And then number 1, 2, 3, number 3. Okay, number 3, breakpoint. Okay, we have another one after breakpoint because if we try to plot it, we have minus 2. Okay, let's say this is minus 1, minus 2. Minus 2 with 2j. Okay, this is 2, j omega. And the other one is minus 2. Okay, and then we have x equals to 0. So you see you have conjugate. And it starts from the imaginary side. So if it's imaginary, you need to find the, what we call it, departure angle. Kalau saya kata dia berada di imaginary area, maksudnya dia ada sudut berlepas. Okay, kita akan kirakan sudut berlepas. Okay, sekarang calculate for break point. So 1 plus kgh. Okay, this is our K as K equals to 0. Then K equal to minus S squared plus 4S plus 8. Okay, ini ada masalah tak yang nak bawa ke sebelah sini? Tak kan? Sebab kalau this one, fraction ni sama dengan minus 1. So minus 1 tu darab dengan ni semua. Bawa ke sebelah sana. Okay. So kita akan dapat this one minus S squared plus 4S plus 8. Okay, dan kita differentiate 2S minus differentiatekan dia, kita akan dapat d over ds as 4 of 3 plus 4s squared plus 8s. Okay, bezakan dia, kita akan dapat yang ni negatif ni kita boleh equals to 0, then we not consider negative anymore. So 3s squared plus 8s plus 8 equal to 0. And then we find for the s. S we use calculator. Okay, directly you can calculate using calculator, or you can use negative b plus minus b squared minus 4ac. So it's 69 divided by 6, 3 times 2a, 2a, 2 times 3. So it's 6. Okay, is minus 8 minus 32, then divided by 6, you have minus 1.33 plus minus 0.943 J. Okay, you see you have two breakpoint. One is at, okay, let's say this is 1. Okay, what will be minus 1.33? 1.33 dekat nyata nyata. So this one is 1 kat sini nyata ni. Less than 1.5. So less than there, and then not more than 1. So it should be here. Okay, imagine that this root, this pulse will come to this point, breakpoint, and then go to the asymptote 60 degrees. Okay, let's say we have 60 degree asymptote here. It's come from here, go there, and we need to calculate for the k, or value at imaginary, similar to this one because it's mirror. Okay, it's mirror image there, and then go here. Okay, you need to hit the imaginary axis, but you don't know the value. We need to calculate the value using the similar 1 plus kgh here. Okay, which one you like? Okay, you can choose either this one, or this one. Okay, so if you see from the notes, okay, it will give you both method. 1 plus kgh equals to 0. So you use the same equation as this one, S3 plus 4s squared plus 8s. Okay, plus k ni k plus this one, so it's plus k equals to 0. Substitute j omega into the s. Okay, factorize the j and the real value. So we have real part and also imaginary part. Okay, which one imaginary part? Okay, imaginary part will give you the answer first. Imaginary part, negative omega power of 3. Okay, omega power of 3 equals to 8. Okay, then go to real part. Okay, for real part we have k equal to 4 omega squared. So what is the omega? Okay, then substitute here. We have to find for k, which is 2. Then we get 32. Okay, what is the meaning of this value? What is the meaning of this value? Omega 2 minus 2. Okay, if you times 2 with 1 plus 1.7 1.7 something. So you get 3, right? 3 something. Okay, so it's 2, then it's hit about 3. Right, it's hit about 3. Okay, what is the 2 times square root of 2? What is the value? 2 times square root of 2. Okay, while we are calculating it, you can use the other rule stability for S. One, 8, 4, K. So this one K, this one, let's say C. So what is the C? 32 minus K divided by 4. So K equal to 32. So K between, so at K equal, at K 32 imaginary, at what we call it, J exists. Okay, we can find for the coordinate. Okay, So we use the second row. For s squared plus k equals to 0. So s squared equals to minus k. K is 32 divided by 2. Divided by 2. Okay. So we have why it's not similar to this one. Okay. 32 minus 4. Minus 4. Okay, minus 4, not minus 2. 32 minus 4. K is minus 32. K equals to 32 minus because we change the position minus K. So minus 32 divided by 4. Okay. Square root of it. Square root of 32 square root of minus okay, let me check. We have K32 K32 using second row for s squared plus K, okay, plus K is 32. Okay, we can factorize 4s squared plus 32 equals to 0. S squared plus equals to 0. So we have s square root of minus 8. Okay, so we have s plus minus 2.83j. So here we have omega 83. Okay. So similarly, you have k and omega. It's 2.83. So it's more than this one. Yeah. So it's supposed to hit the breakpoint and go to here. Similarly to this one. Okay, maybe we can draw it properly using the asymptote and also the real axis. Okay, we draw the axis first, and then you use the graph paper. You need to have a graph paper, a plain graph paper. You can download from the internet and print it, or you can buy one set of book for plain graph paper. Okay, so we have 0 here, 0, and then you have, let's say, 1 and minus 1. Okay, 0, 1 and minus 1. Okay, never mind. We change the location. Let's say 1 here, 1, and then minus 1. Minus 1 and minus 2. So the poles locate at minus 1, minus 2, minus 2, minus 2. So this one, 1, this one, 2. We have 1 here and the other one here. Okay. Okay, this is our pole. Somewhere here. and dia ada -2 and -2. Okay, for asymptote dia akan kena pada -1.33. Okay, let's say -1.33 kat sini. Kita ada 3. Okay, 1. Okay, let's say 1. Kita anggar je. 1, 2, 3 here. So 1.33 lebih kurang dekat sini lah. Kat sini. So 60 degrees. Okay, 60 degree from there. $60 from that point. Okay, dia ada 300 degree. Bergerak pula dia. Okay, macam tu. Jadi saya kena habiskan yang ni lah. Tak nampak sikit. Okay, tak apalah macam tu Okay, so dia ada poles 0 kan. Okay, now we have the breakpoint. Breakpoint is -1.33, 0.943. Okay. Sorry. Okay, dia atas asymptote So atas asymptote pada 0.94 maksudnya less than 1. Okay, less than 1. This is 1. Kurang sedikit daripada situ. So this is breakpoint. Okay, atas asymptote tu, lepas tu kurang daripada 1. Okay, dan cut at imaginary axis pada S sama dengan 2.83. Okay, 2.83. Let's say sini 3. 2.8 tu kat sini. Okay, let's say ni 2, ni 3. 2. Okay, dia sepatutnya sama tau dengan kat bawah tu. Ni 1, 2, 3 sini. 2.83 mungkin kat sini. Okay, sekarang kita ada 3 point. 1 from the post, then breakpoint, and then yang ini. Okay. Sekarang kita nak lukis dia punya curve dia. Macam tu. Jangan berliku-liku ni. Okay. Tak boleh sebab dia cap. Kena tengok daripada jauh. So dia ada pose ni, dia akan straight line macam tu. Okay. Apa ni? Anggap je dia straight line sebab saya tak boleh nak lukis. Dia ada, tak tahu kenapa, mungkin kena pakai line yang lagi tebal kot. Okay. So yang ni pun sama. Saya kena pakai yang lagi tebal. Sama je, dia sengit-sengit juga. So that's it. That is how the focus looks like. Okay. So tadi, okay, one more. There is a one of what we call it, the angle of departure. Saya tak kirakan tadi angle of departure. Okay, tadi we have berapa step tadi? 1, 2, 3 kan? Breakpoint, lepas tu yang ni. Okay, 2, 3, yang ni 4. Okay, yang value kat that imaginary axis and K at that imaginary axis. So yang kelima, our step is angle of departure. Okay. Actually, we need to calculate this one first before we draw. So angle of departure, let's say theta d equal to the summation of poles angles, meaning that if you want to calculate, determine the angle of departure for this poles, then you can then you need to calculate the angle of this one to this pole. Okay, 0 pole to imaginary complex pole ni. So yang ini actually kalau betul-betul pakai pembaris kan, you boleh kira ni sudut dia 45 degrees and the other one ni adalah 90 degrees. Okay, so kita kira 45 tu adalah dari sini, ni adalah dari sini. Okay, so kita ada 45 plus 90. Okay, the summation of all poles angle from that pole yang kita nak kira dia punya angle of departure tu, okay, plus 180 degrees. So yang itu kita akan dapat 45 degrees. Okay, yang ini sepatutnya 45 degrees ini 45 degrees. Nanti kamu kira betul-betul lah. Okay, sepatutnya ikut macam ni dan pergi macam tu. Okay, yang tu saya sketch je. But we need to calculate for angle of departure. Okay, one is 90 degree, the other one is 45 degrees. Okay. So kita ada A, B, C saya dah bincang. So D, E tu saya akan bincang kat kelas lain. Okay. And I will share with you for the other root locus plot. Okay. I have another 2. So kita ada kat sini section 4 section kan. So another 2 section tu nanti saya akan bincang, ataupun the other 2 hours tu saya akan bagi je yang ini. For example. Okay, I think that's all for our class today. Ada soalan tak? Okay, kalau tak ada soalan, kita sampai sini je. So saya dah habiskan root locus. Saya akan bagi lagi contoh root locus untuk ada 4 lagi untuk kita lukis dan kita tahu teknik dia lah. Lepas tu untuk soalan root locus adalah soalan memang sentiasa ada lah dalam soalan exam dan juga test 2. Okay, test 2 lama lagi kan. Lepas tu dia ada satu lagi yang tambahan bila selesai semua root locus, kita kena cari operation point. Okay, kenapa kena ada operation point tu? Sebab untuk operation point tu kita nak design controller pada karakteristik point tu. Contoh kita nak ada satu operation point pada zeta 0.5 contohnya. So 0.5 tu locate kat mana atas root locus tu. Yang tu kita kena belajar nanti. Yang tu yang terakhir bila kita dah pandai draw semua. So untuk buat root locus kita sepatutnya ambil masa 2 minggu lah. Tapi saya akan jawab dalam masa 1 minggu je. Jadi awak kena belajar sendiri untuk lukis. Sebab dia punya step sama je. Cuma equation dia tu yang akan jadi susah. Sama ada bila dia terlalu susah, breakpoint tu akan diberikan. Kadang-kadang tak diberikan, awak gunalah polynomial solver tu kat dalam, mungkin kat dalam ni pun ada kan. Ataupun pakailah negatif B tu. Kalau S kuasa 3 tu dia susah kan nak cari dia punya S tu. Kalau S kuasa 2 tu boleh lagi pakai calculator. So saya rasa yang itu saja. Yang terakhir tu adalah operation point. How to calculate ataupun apakah our transfer function tu jika diberi nilai zeta pada titik operasi tu. So yang tu kemudian kita akan buat. So ada soalan tak? Kalau tak ada kita
Doktor, ada ambil attendance ke?
Okey, siapa yang belum ambil attendance tu boleh kemudian kejap. Ada soalan tak? Kalau tak ada saya ambil attendance untuk section 9 je. 9 dengan 10. Betul Fikri? Section berapa?
Saya section 10.
10 betul. Okey, so section 11-12 tak ada soalan Okey, kalau tak ada soalan